Hello everyone, thank you for attending this presentation about vehicle level GT Suite toolset for BEV thermal architecture design. This presentation focuses on a new modeling approach to design thermal loops and cooling module. This new approach is actually launched in Stellantis group to face challenges of electrified powertrains. Nevertheless, with regard to the last complicated year, the study is not completely finished yet, and many points are still in investigation. So, few results are shown in next pages, and I'll be glad to present the full picture with more detailed results in a new next GT conference. Let's start with the contents. First, a short introduction to the thermal design context. Then, a focus on needs and objectives, an explanation of model layouts and model features, some examples of simulation results, and then conclusions and perspectives. About the context, I will start with the challenge of BEV thermal architecture design. There are currently many vehicle features in interaction and also trade-offs between dynamics, cabin comfort, charging time, cost, aging, and autonomy. Also, there is a diversity of technical solutions, including different cooling solutions, different fluids, or combination of fluids. And there are various technologies and thermal input, synchronous, asynchronous machines, IGBT versus silicon carbide technology for inverters, and so on. So the challenge is to do the right choice for the best performances, the lowest cost, and to do this in a short period of time, for instance, in the early step of the project. Needs and objectives. The thermal engineer needs to evaluate performances of different concepts in the early steps of the project and to select the most appropriate one regarding project's objectives and constraints, taking into account performances but also cost and packaging. So, requirements for this GT Suite toolset are first, a capability to do quick evaluations because there are many concepts to evaluate in the early steps. The tool reactivity is also a key point. Second, a functional approach with high-level input data because few data or models are available at this phase and gross assumptions for system are usually made. So, if I sum up key points about this modeling approach, point 1, 1D plus Call 3D needs for fluids, loops modeling with of course transient simulation needs. Point 2, one model for one mode, which means separated models for each functional mode in order to get very simple models. And point 3, system-based model with high-level data in order to have an easy-to-use tool for users. On this model layout and features page, we introduce the simplified modeling approach. On the left side, you can see different types of thermal modes, including different ways to transfer heat, for example, direct or indirect transfer for AC loop with a direct condenser or a water condenser, and in this case the heat from the AC loop is transferred to coolant and then to the external air through a